Method syntax. Methods are similar to functions. We declare them with the fn keyword and a name. They can have a parameters and a return value. And they contain some code that runs when the method is called from somewhere else. Unlike functions, methods are defined within the context of the struct. So unlike this is something different from functions. Methods are defined within the context of a struct, or an enum or a trait object, which we cover in chapters 6 and 17, respectively. And their first parameter is always self. Okay, which represents the instance of the struct the method is being called on, which represents the instance of the struct. Okay, so self represents the instance of the struct, and the method is being struct instance of the struct. The method is being called on. Makes sense. So defining methods, let's change it the area function that has a rectangle instance as a parameter, and instead make an area method defined on the rectangle struct as shown in listing 5-13. Defining methods. Let's change the area function that has a rectangle instance. The area function that has a rectangle as a parameter, and instead make an area method defined on the rectangle struct. As shown in listing 5-13. So rectangle and then area and rectangle and rectangle rect1 area. Defining an area method on the rectangle struct. To define the function within the context of a rectangle, we start an implementation block for rectangle. Everything within this impl block will be associated with the rectangle type. Then we move the area function within the impl curly brackets and change the first, and in this case only parameter, to be self in the signature and everywhere within the body in main, where we call the area function and pass the rect1 as an argument. We can instead use a method syntax to call the area method on our rectangle instance. The method syntax goes after an instance. We add a dot followed by the method name, parentheses, and any arguments. In the signature of area, we use ampersand self, reference self, instead of rectangle. The self is actually short for self. Within an impl block here. This ampersand self means that self and type ampersand self. The type self is an alias for the type that the impl block is for. Okay. Methods must have a parameter named self of type. Methods must have a parameter named self of type self for their first parameter. So Rusty lets you abbreviate this with only the name self in the first parameter spot. Note that we still need to use the ampersand in front of the self shorthand to indicate this method borrows the self instance, just as we did in rectangle. Methods can take ownership of self. Borrow self immutably as we've done here, or borrow self mutably just as they can any other parameter. Okay, so methods can take ownership of self, and so we have to borrow it. We've chosen self ampersand self here for the same reason we use the ampersand rectangle in the function version. We don't want to take ownership, and we just want to read the data in the struct, not write to it. If we wanted to change the instance that we called the method and on as a part of the what the method does, if we wanted to change the instance, if we want to change the instance that we've called the method on, as part of what the method does, we use mute self as a first parameter. Having a method that takes ownership of the instance by using just self as a first parameter is rare. This technique is usually used when the method transforms itself into something else, and you want to prevent the caller from using the original instance after the transformation. The main reason for using methods instead of functions. The main reason for using methods instead of functions, in addition to providing method syntax and not having to repeat the type of a self in every method signature, is for organization. Makes sense. We've put all the things we can do with an instance of the type in one input block rather than making future users of our code search for capabilities of research rectangle in various places in the library we provide. Note that we can choose to give a method the same name as one of the structed fields. Note that we can choose to give a method the same name as one of the structed fields. We can choose to give a method the same name as one of the structured fields. For example, we can define a method on rectangle also named width. Oh, okay. Here we are choosing to make the width method return true if the value is in the instances which field is greater than 0, and false if the value is 0. We can use a field within a method of the same name for any purpose. In main, when we follow rect1.width with parentheses, roster knows we mean the method width. When we don't use parentheses, roster knows we mean the field. Oh, makes sense. Often, but not always, when we give methods with the same name as a field, we want it to only return the value in the field and do nothing else. Methods like these are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Often, but not always, when we give methods with the same name. Often, but not always, when we give methods with the same name as a field, we want it to only return the value in the field and do nothing else. Methods like these are called getters, and Rust does not implement them automatically for struct fields as some other languages do. Getters are useful because you can make the field private, but the method public, and thus enable read-only access to the field as a part of the types public API. We will be discussing what public and private are and how to designate field or method as public or private in chapter 7. Where's the operator? In C and C++, two different operators are used for calling methods. You use dot if you are calling a method on the object directly, and arrow if you are calling the method on a pointer to the object and need to dereference the pointer first. In other words, if object is a pointer, object is something. It's similar to object is something. Rust doesn't have an equivalent to the arrow operator. Instead, Rust has a feature called automatic referencing and dereferencing. calling methods is one of the few places in Rust that has this behavior. Here's how it works. When you call a method with the object.something, Rust automatically adds in ampersand mute or star so object matches the signature of the method. So object matches the signature of the method. In other words, the following are the same. P1 distance. P2 reference. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver. The type of self given the receiver and name of a method, Rust can figure out definitively whether the method is reading itself or mutating or consuming itself. Given the receiver and name of the method, Rust can figure out definitively whether the method is reading, mutating, or consuming. The fact that Rust makes borrowing implicit for method receivers is a big part of making ownership ergonomic in practice. The first one looks much cleaner. This automatic referencing behavior works because methods have a clear receiver. Oh, it's automatic referencing. Okay, it's actually automatic referencing. So it's just reading it. Okay, makes sense. Methods with more parameters. Let's practice using methods by implementing a second method on the rectangle struct. Let's practice using methods by implementing a second method. Second method. Second method on the rectangle struct. This time we want an instance of a rectangle. We want an instance of rectangle to take another instance of rectangle. And return true if the second rectangle can fit completely within self. The first rectangle, otherwise it should return false. That is, once we've defined the can-hold method, we want to be able to write the program shown in listing 5-14. 5-14 using the as yet unwritten can-hold method, and the expected output would look like the following. Because both dimensions of rect2 are smaller than the dimensions of rect1, but rect3 is wider than rect1. We know we want to define a method, so it will be within the impl rectangle block. We know we want to define a method. So it will be within the impl rectangle block. We know we want to define method, so it will be within the rectangle block. Okay. The method name will be can-hold, and it will take an immutable borrow of another rectangle as a parameter. And it will take an immutable borrow of another rectangle as a parameter. Immutable borrow, yep. We can tell what the type of the parameter will be. We can tell what the type of the parameter will be by looking at the code that calls the method. We can tell what the type of the parameter will be by looking at the code that calls the method. Rect can hold rect passage rect2, which is an immutable borrow of rect2, an instance of rectangle. This makes big sense because we only need to read rect2 rather than write, which would mean we need a mutable borrow. And we want main to retain ownership of rect2. We want main to retain ownership, so we can use it again after calling the canHold method. The return value of a canHold will be a boolean, and the implementation will check whether the width and height of self are both greater than width and height of the other rectangle, reference respectively. The return value of a canHold will be a boolean. The return value of a canHold will be a boolean, and the implementation will check whether the width and height of a self are both greater than the width. I believe we check whether the width and height of a self are both greater than the width of the other rectangle. Respectively, let's add the new canHold method to the input blocks from listing 5-13 shown in listing 5-15. When we run this code with the main function in listing 5-14, we will get our desired output. When we run this code with the main function, in listing 5-14, we will get our desired output. Methods can take multiple parameters that we add to the signature after the self parameter, and those parameters work just like a parameters in function. Associated functions. All functions defined within an input block are called associated functions because they are associated with the type named after the input. We can define associated functions. That don't have a self. We can define associated functions that don't have a self as their first parameter and thus are not the methods. Okay. Because they don't need an instance of the type to work with. We've already used the one function like this string from function that's defined on the string type. Associated functions that aren't methods are often used for constructors that will return a new instance of the struct. Associated functions that aren't methods are often used for constructors that will return a new instance of the struct. These are often called new, but new isn't a special name and isn't built into the language. For example, we could choose to provide an associated function named square that would have one dimension parameter and use that as both width and height, thus making it easier to create a square rectangle rather than having to specify the same value twice. We could choose to provide an associated function named square that would have one dimension parameter, and use that as both width and height, thus making it easier to create a square. Okay, makes sense. The self keywords in the return type and in the body of the function, all aliases for the type that appears after the input keyword. The self keyword in the return type and in the body of the function or aliases in the body of the function keyword is set of keywords. In the return type and in the body of the function or aliases for the type that appears after the input keyword. So this rectangle, which in this case rectangle. To call this associated function, we use the double colon syntax with the struct name let sq equals to rectangle double colon square 3. It's an example. This function is a namespace by the struct. Double colon syntax is used for both associated functions, and namespace is created by modules. We will discuss modules in chapter 7. Multiple input blocks. Each struct is allowed to have multiple input blocks. For example, listing 5-15 is equivalent to the code shown in listing 5-16, which has each method in its own input block. There's no reason to separate these methods into multiple input blocks here, but this is valid syntax. We will see a case in which multiple input blocks are useful in chapter 10, where we discuss generic types and traits. Summary: structs let you create custom types that are meaningful for your domain. Structs let you create custom types that are meaningful for your domain. By using structs, you can keep associated pieces of data connected to each other and name each piece to make your code clear. In input blocks, you can define functions that are associated with your type, and methods are a kind of associated function that let you specify the behavior that instances of your structs have. Structs let you by using struct you can keep associated functions your code clear. In input blocks, you can define functions that are associated with your type, and methods are a kind of associated function that let you specify the behavior that instances of your struct have. A kind of associated functions that let you specify the behavior. Let you specify the behavior that instances of your structs have. But structs aren't the only way you can create custom types. Let's turn to Rust's enum feature to add another tool to your toolbox. What is the keyword for constructors in Rust? New. Oh, the name of the type being constructed. None of the above. No, the name of the type being constructed. What is the keyword for constructors in Rust? None of the above. Determine whether the program passes the compiler. Struct point, so it's a tuple struct, and then 5012, and then I32 import, so I32 and then self.0 1, so p.x 1 1. Consider those two methods that increment the field of struct. Consider those two methods. Those two methods increment the field of struct. Which style would be more idiomatic for Rust? It's immutable. It's just immutable and then consuming. So it's not reading it, but it's actually writing it. So writing each increasing value. Surface consumed. Setting the second one. Determine carbon capacity compiler. So increment expects p point 0, 0, in 3x 1 plus 1 does it compile and 1. Wow, okay, determine. So get x emit self emit I32. What? Weird. P point x y get x mutable self and then mutable reference to I2 I32. Mutable reference to self x. It's a mutable reference and it's a mutable reference, but dereferencing it. This will throw an error. Oh no. Mutable reference. That's a mutable reference. Mutable reference. So +1 and p dot y dot x. Two. So I guess 2. 2. 2. 2. 2. 2. Ah, shit. Self 0. P point 1 2 P just x and self 0 1. Point 1 2 1 2. That's oh, this is simple P. What the heck? This is in the inside it. Shit. Yeah, it's wrong. And then pull P here. control. Point 1, 2. Get X self um 1 turn 1. Not sure about this. Program does not compile the error occurs in the line number 5. Yes. But this one program does not compile. The error occurs on the line number 16. Oh. Okay, so this worked. So this should